How do you use solubility curves? Well, first, what are solubility curves? A solubility curve displays the required mass of a substance that is needed to create a saturated solution. If a point is below the solubility curve, then the solution is unsaturated. If a point is on the solubility curve, then the solution is saturated. And if a point is above the solubility curve, the solution is supersaturated. So let's take a look at a problem. How many grams of sodium nitrate are needed to create a saturated solution in 100 grams of water at 30 degrees Celsius? So we're given this chart here, which tells us the solubility in grams of solute over 100 grams of water. And we simply need to find the curve that resembles with sodium nitrate, NaNO3. And we now need to draw a line from 30 degrees Celsius up to our solubility curve. Now that we have found where we are on a solubility curve, we can simply read the graph to see how many grams of solute are required to make a fully saturated solution. And it's approximately 95 grams of sodium nitrate. Let's take a look at another problem. If 60 grams of hydrochloric acid is dissolved in 100 grams of H2O at 18 degrees Celsius, is the solution unsaturated, saturated, or supersaturated? So firstly, we must make sure we're using the solubility curve for hydrochloric acid. And we must now draw a line from 18 degrees Celsius up to 60 grams. So since the point is below our hydrochloric acid solubility curve, that means that the solution is unsaturated. So let's look at another problem. How much more potassium nitrate is dissolved at 70 degrees Celsius than at 20 degrees Celsius in 100 grams of water to form saturated solutions? So first, let's distinguish to use the potassium nitrate solubility curve. And then let's draw a line, one from 20 degrees Celsius and one from 70 degrees Celsius. And now let's read the graph. So after reading the graph, we can see that about 35 grams of potassium nitrate is dissolved to create a saturated solution at 20 degrees Celsius. And about 135 grams of potassium nitrate is dissolved to form a saturated solution at 70 degrees Celsius. We can now subtract the two values to find the difference. And we get about 100 grams of potassium nitrate. Let's take a look at another problem. How much more ammonium chloride is required to saturate a solution if 40 grams of ammonium chloride are dissolved at 90 degrees Celsius? So let's first distinguish that we're using the ammonium chloride solubility curve. Then let's see how many grams of ammonium chloride are required to dissolve at 90 degrees Celsius to create a saturated solution. So you need approximately 72 grams of ammonium chloride to dissolve at 90 degrees Celsius to create a saturated solution. So if we subtract the 40 grams that we've already dissolved, we will solve for the amount that we need to add to create a saturated solution. And we get approximately 32 grams of ammonium chloride. Let's take a look at one last problem. How many grams of potassium chloride is required to create a saturated solution in 500 grams of water at 50 degrees Celsius? So unlike the previous problems, we're working with 500 grams of water as opposed to 100 grams of water, which is what the table works with. So first, let's distinguish that we're using the potassium chloride solubility curve, and then draw a line from 50 degrees Celsius up to the curve. We can now see that it takes approximately 42 grams of potassium chloride to dissolve to create a saturated solution. However, we don't have 100 grams of H2O like the other problems and how the table works. So we have to convert it to 500 grams of H2O. To do this, we can simply set up a stoichiometric equation which converts the 42 grams of KCl per 100 grams of H2O to how many grams of KCl we need per 500 grams of H2O. And we get approximately 210 grams of potassium chloride. Thanks for watching. Like and subscribe.